Good evening, everybody, and welcome to tonight's monthly webinar from the AHDB Cereals and Oilseeds Knowledge Exchange team. Tonight we are making the most of muck, and there's never been more talk about nitrogen and all of those sorts of things, with both the implications of the farming rules for water as well as the sky-high fertiliser costs. So it's a great night to have that. But before we kick off with anything, as always, we're going to look at some housekeeping. So if you're not aware, you are muted. We can't see or hear you in the background. If you want to ask questions, you can send those in to us in the chat box on the GoToWebinar software. And we do encourage questions. There is a formal Q&A session at the end of the speakers, but if you send them through as they come up, we will keep a track of those and get as many answered as possible. We should be finished about 8:15 tonight, so you can get a bit of your evenings back, and we will do our best to keep to time. You should have been asked for your basis and Naroso details as you registered for this webinar, and if you have filled those in, we will make a record of who's attended and get those points accredited. But if you didn't complete that or you missed those, you can send them in again in the chat box, and we will get those added to the register. And then finally, this is a recorded webinar. All of our Cereals and Oilseeds webinars are recorded, so that you can go back at any time and have a look at the content, or equally if you have to leave for any reason, you won't miss out. As with everything, we are on Twitter. You can give us a follow at AHDB_cereals, and we often use the hashtag #monitorfarm. So on tonight's agenda, we are going to swiftly move into looking at the farming rules for water with James Holmes from AHDB. And then the main thing we're going to do is, we know the implications of the rules, but what we are looking at is how we can then make the most of muck to get the most from it in the most effective way. As I said, there'll be a Q&A session, and then we'll wrap up at 8:15. So that leaves nothing further to be said, really. But all I can do now is introduce James Holmes, who is a senior scientist in our AHDB environment team, who's going to talk through the implications of farming rules for water. Over to you, James.
Thank you very much, Michelle. Good evening, everybody. My name's James, and I work for AHDB. I'm a senior scientist in the environment team, I'm part of the team that publish RB209, and we work with farmers and growers to support the challenges you face, and we also work very closely with DEFRA, with the Environment Agency in England as well, to help facilitate a discussion about rules and regulations, one of which over the past 18 months has been farming rules for water. So a couple of things I want to talk about. One, the rules themselves, clearly. Two, the role AHDB plays. I think that's really important. I think probably some of you at least will have been told that the Environment Agency are simply implementing rules that are written within AHDB's RB209. So I want to address that up front as well, and then talk about perhaps how this relates to the price of fertilizer, which will lead really nicely into to Lizzie's presentation following me. So farming rules for water were introduced by DEFRA in 2018. 8 seemingly simple rules introduced around about 4 years ago, with to little effect initially. But over the past 18 months or so, the Environment Agency have been tightening those rules and that interpretation of the rules, and how they expect farmers and land managers to manage muck has become clear. And particularly Rule 1, which has had pretty profound implications for the way that we use mucks and all types of organic materials. And essentially what that boils down to is now that the Environment Agency are saying that you can only use that material in the autumn or winter if the crop that's being applied to has a nitrogen requirement in that season. And the reasons that they're doing that are essentially to protect water quality. The farming rules for water, and there's nitrogen in the water, and that's causing pollution. Some of that nitrogen is coming from farming. I think it's really important to acknowledge that, but it's not all coming from farming as well, and that is acknowledged. It's acknowledged by everybody in that's involved in this. But some of it is coming from agriculture. And so the Environment Agency is saying, look, and if there isn't a nitrogen requirement, you don't need to apply that for wheat, then you shouldn't apply that material, and that's many people have said that's based on the rules and the regulations in RB 209. Well, first of all, RB 209, as published certainly by AHDB now, is not a rule or a regulation. It's guidance. It's national guidance produced very under very strict and robust science that underpins that guidance, but it's not a rule, it's not a regulation, and it simply is guidance that can be interpreted in different ways in different parts of the country and different farming systems. And also, I think probably the most important thing to say is that guidance that's written in RB 209 deals with nitrogen and nitrate pollution, and AHDB, as these rules started to crystallize earlier this year, AHDB funded a piece of work again with ADAS and Lizzie's colleagues to look at what the implication this might be if we simply move all of that application of whatever that is, biosolids, farmyard manure, slurries, and if we move all of that from the autumn and apply that in the spring, what effect is that going to have? What are the things that are we going to need to think about, in order to make that happen, if that's the case? And what's that shown quite clearly is that while nitrate pollution would be reduced, the modelling that ADAS did has shown that the nitrate pollution is likely to reduce by about 60%. The danger is that phosphate pollution, which, as many of you will be aware, can be quite a significant pollutant in water, and ammonia emissions to air could also could increase as a result of that. So I think it's really important to understand that while RB 209 does provide some guidance around the use of nitrogen in the autumn, it provides some guidance around how you might use and make best use of manures. It's guidance that was written some time ago and could be improved based on a different way of managing manures, and AHDB is looking very closely at that at the moment in terms of how that guidance might evolve over the coming months. In terms of the future, the Environment Agency are looking to be fair to the Environment Agency, they're looking to develop their guidance for how farmers might meet the rules and the regulations. And AHDB, myself, and colleagues are part of an industry working group that are looking to develop, if we call it like a more sustainable solution that enables, perhaps, I can make no guarantees, but perhaps enable some materials that are low risk, and for example, farmyard manure. Could you use farmyard manure in a situation in the autumn that really doesn't pose that much risk, and means that you realise all of the benefits of using that material? Clearly, you have nitrogen in that material, but you have phosphate and other elements, and you're also able to build soil carbon and improve soil health as well. So there's lots of reasons why we might use this material. So that's what AHDB is working on at the moment, and that's a priority. That's a top priority for us as an organisation, is to be able to work with the Environment Agency to understand, how we might use these materials sustainably, and then, potentially in the future as well, revise RB 209 so that guidance is more balanced in terms of nitrate pollution, but also phosphorus and ammonia, and the benefits of using these materials for, to build soil health. Of course, with the price of fertilizer as it is, nitrogen, but also phosphates, have been very expensive as well, very costly, I should say. What that means is that, not only with the pressure of farming rules for water, but with the price of fertilizers, it's obviously really important to make use of the elements, the nutrients that we have. So, I'm very pleased that Lizzie's going to talk us today, through those options that we have, and will give us a masterclass today. That's kind of my brief introduction and explanation of the rules and AHDB's approach to working with the EA to develop a more sustainable solution. And I'll be available to answer questions in the Q&A at the end of the webinar.
Fab, thank you, James. That was a great introduction. I will ask you one question to start in case anyone wants to be going off to beaver away at this. Where can people find the rules and regulations written down? Do you know best place to send people to find the...
Yeah, absolutely. That's on gov.uk simply. But what I'll do now, just through this next session, is I'll pull out the links and I'll put them in the chat, if that would help.
That'd be brilliant. Thank you, James. That's a great introduction to why this session is so important. So James will be about for the Q&A, and what we'll do now is we'll move on to our second speaker, who is Lizzie, who is going to talk to us about how we can make the most of our muck. So we've got the muck and we want to get the most from it. So Lizzie, over to you.
Perfect. Thank you very much, Michelle. So this is actually one of my most favourite topics to present on, so it's great to join you all this evening. So this is just a general outline of what I want to cover. I've been with ADAS now for about 18 years, and most of that, quite a bit of that time, I've spent working on various projects, looking at making the most of manures, so I can integrate that to the presentation today. So yeah, so this is what I want to broadly cover. We'll look at different nutrient values of manures. So we'll spend quite a bit of time looking at nitrogen in manure, in particular, what we can do to minimise nitrogen losses and try and maximise the crop available nitrogen supply from manures, and also then look at the other nutrient value of manures, the phosphate, potash and sulphur content. If we've got time, we'll also look a bit at the organic matter value of manures as well. So we've got about 35 minutes to fit that in and cover those tonight. But before we jump into that, if you've got manure on your farm, one of the probably key questions that you've got at the moment is, what's it worth? So hopefully you can see my laser pointer on the screen. Hopefully we all know already that manures are a valuable resource. They contain nutrients and organic matter, and that nutrient has a value in terms of the fertilizer value of the manure, and we can put a value on that by comparing to the current value of fertilizer. So just taking as an example, say you've got cattle manure, cattle FYM, and you're spreading that at 40 tonnes per hectare. Say you're spreading it in the spring, you're surface broadcasting it. So with that manure application, you would be supplying about 24 kilograms per hectare of crop available nitrogen, 128 of total phosphate, and 376 kilograms per hectare of total potash. Now, given the increase of fertilizer prices, we're all sort of suspecting that the value of that material has increased substantially over the last year or so. I just crunched some numbers earlier today in terms of what that material is worth, and also comparing back to the value sort of early last year. So we can do that by looking at fertilizer prices. So here I've worked out the value of this material back at the beginning of last year based on prices then. So then we've got ammonium nitrate about £236 per tonne, triple superphosphate at 280, and muriate of potash at 269. And from those values, we can work out the price of the nutrients in pence per kilogram or pounds per kilogram. So based on those prices, back at the beginning of last year, our cattle manure you can see its value in pounds per tonne there. So 41 pence per tonne of crop in terms of its nitrogen value, £1.95 in terms of phosphate, £4.21 in terms of potash. So it has a total value of £6.57 per tonne in terms of its nutrient value. And if you were to apply that at a rate of 40 tonnes per hectare, that's worth to you £263 per hectare. So obviously you've got to caveat that that's its nutrient value. It doesn't include handling or spreading costs. We've based those values on the comparing to straight fertilizer prices, and you could possibly purchase those in compound a bit cheaper. But let's compare to fertilizer prices today. So I think this is about right. I think at the moment we're looking at AN about £500 per tonne, triple super at just over £500 per tonne, and muriate of potash at £440 per tonne. So looking at those prices, you can see that today that our cattle manure has increased in value. It's worth just over £11 per tonne, and just that 40 tonnes per hectare application is worth about £450 per hectare. So it's almost doubled. Its nutrient value has almost doubled since last spring. Similarly, using the same fertilizer values, just looking at another example, pig slurry applied at 50 metres cubed per hectare, assuming a spring surface application, broadcast application. This material, a bit different to cattle manure, we've got more readily available nitrogen there. So this application would supply just under 100 kilograms per hectare of crop available nitrogen, 75 of phosphate, and 110 of potash. So spring last year, this material was worth £3.25. It should be pounds per cubic metre. And this application at 50 cubes per hectare would be worth about £163 per hectare. Today, increase in fertiliser prices, that's now worth to you about £6 per metres cubed, and £300 per hectare. So given given that value we've got there, it's important that we can take some time to make sure that we are taking steps to maximise that nutrient value of that material to you. So organic materials, livestock manures, biosolids, digester, all these types of organic materials, they contain crop nutrients and they also contain organic matter. So I think we know that we're viewing these materials as a resource for you on your farm. But poor management of these materials can cause diffuse pollution of the environment via nitrate leaching and gaseous nitrogen emissions. And so we need to try and have management strategies that minimise these nutrient losses whilst maximising their value, in particular that of the crop nutrient value. But it's complicated, particularly for nitrogen, which doesn't necessarily stay where you want. When you apply manure, some of the nitrogen is in the readily available form, readily available ammonium form. The rest of it is in the organic nitrogen form, which will mineralise slowly over time. Now, some of this ammonium may be lost via volatilisation fairly soon after application. We might also lose a bit via denitrification. Some of it will nitrify to nitrate and may be lost via leaching, which is mainly a problem if we're applying the material in the autumn-winter period, whilst what we really want is to get as much of it as possible into the crop. Now, over the last few decades, there's been a significant research effort, both in the UK and elsewhere, focused on manure management. This research has been driven by the need to inform policy and support farmers. So, for example, in the UK, ourselves at AHDB and Rothamsted Northwick have done a lot of research on manure application timings to provide the evidence base for our nitrate vulnerable zone closed spreading period. And much of the research we've done has focused on understanding the factors that affect nitrogen losses, such as leaching and ammonia volatilisation, and also trying to be able to estimate the crop available nitrogen supply. So we can bring that all together to try and provide guidance to farmers on manure management strategies which minimise these losses and maximise the crop nutrient value. Now, whenever we do a making the most of manures presentation, this is what we say you should be doing in order to make the most of your manure nutrients. So follow these steps. So first of all, make sure you've got reliable information on the manure nutrient content. How much nitrogen, phosphate, potash is actually in the manure that you've got on your farm. Secondly, you need to estimate how much of those nutrients will become available to your crop. Thirdly, where possible, take steps to minimise any nitrogen losses. Then when you come to spread the manure, we emphasise the importance of spreading accurately and evenly at appropriate application rates. And finally, we need to build it into the farm nutrient management plan. So once we've worked out how much nitrogen, phosphate, potash the manure is supplied, we need to make sure we reduce our bagged fertiliser use accordingly. So we start off thinking about, working out how much nutrients is in my manure. We know the nutrient content of manures and slurries can be very variable for a number of reasons. The main factors affecting nutrient content are livestock type and diet. So obviously what goes into the animal is going to affect the nutrient content of what comes out. For solid manures, bedding type and the amount of bedding used will affect the nutrient content. Also for farmyard manures, storage and particularly length of storage can affect the nutrient content. So manures that are stored tend to be lower in ammonium end content as the ammonia is lost via volatilization or immobilized within microbial biomass. For slurries, after diet, the main factor affecting nutrient content is dry matter content. The majority of the nutrients are in the solid material, so thicker slurries have a higher nutrient content, and we do tend to see quite a good relationship between slurry dry matter content and total nutrients. Wash water, rainwater entering stores will dilute the slurry. And the other important thing to take into account is slurries will tend to settle out during storage as well, and cattle slurry in particular can crust. So what guidance can we give on manure nutrient content? We do have standard or typical figures of the nutrient content of a range of different types of organic materials, and these values are published in the AHDB Nutrient Management Guide and elsewhere as guidelines for farmers. These are standard figures and they are based on the analysis of a large number of samples, so that they're averages. They do provide useful guidance and a good starting point for manure planning, but just to emphasize the point that they are averages and manure nutrient content can vary considerably between farms. So I would advise you, if possible, to take a sample of your manure and get it analysed, because this will improve the accuracy of your nutrient management. If you're looking at taking samples, you need to look at getting analysed for dry matter content, total nitrogen, ammonium, total phosphate, potash, magnesium and sulphur. If you've got poultry manure, you should also be getting analysed for uric acid, nitrogen. Key thing here is just to make sure you take a representative sample. Now, if you look on the AHDB website, there is good guidance there on how to take a representative sample. General guidance is if it's solid manure, you want to be taking at least 10 subsamples and mixing them together. If you're liquids, take at least 5 2-litre samples of slurry and mix it together before you send it off to the lab. But I would definitely say that's well worth doing. For slurries, you've also got the option of using on-farm testing, and it can be useful to supplement lab analysis with this sort of on-farm testing. So slurry hydrometers can be used to measure the slurry dry matter content. You can see a picture of one here. You basically can drop it in a bucket or container of slurry and it will float and you can read off the dry matter content. We've also got other meters, things like the Quantifix or Agros, which can be used to give a quick and accurate measurement of the readily available end content of slurries. I'm not sure, last time I checked, you could still get these from Transbred, but I'm not sure how widely used they are, but we did some work on them several years back and they give a good accurate measure of the ammonium end content. I would definitely say if you've got slurry, having a hydrometer is worth getting. So I've said that standard figures for manure nutrient content, they're averages and there can be quite a bit of variation in the nutrient content, and this graph is useful to illustrate this point. What we've got here, this is for cattle slurry. We've got the total nitrogen content plotted against the dry matter content for a large number of different samples. This actually is the database that we use to calculate the average figures, the typical figures for cattle slurry that are in our RB209. There's a couple of things to point out here. Firstly, as you can see, I was saying that there's a good relationship between slurry nutrient content and dry matter content. You get a relationship here. However, you can also see the data is quite variable with quite a bit of scatter above and below the line. So if we were just to consider a 6% dry matter cattle slurry, the typical figure for a 6% dry matter cattle slurry in RB209 is 2.6 kilograms per cubic meter. But if we were to look here within this data set, if we take 6% here, you can see that we've got samples that varied between 1.2 and 4.5 kilograms of nitrogen per cubic meter. So quite a bit of variation. Although this data here is for nitrogen, it's a similar pattern for other manures and other nutrients, and it emphasises the point that organic materials can be quite variable in their nutrient content, and ideally get a sample analysed so you know exactly what you're spreading. One other thing that's important to consider when sampling and spreading slurries is I think I mentioned this earlier, they settle out in store. With higher dry matter sinking to the bottom, and the higher the dry matter material has higher contents of nitrogen, phosphate and potash. So we did some work a few years ago where we measured the dry matter content of slurry, pig slurry, at different depths in the store, both before and after stirring. You can see this, the blue line is unstirred and the red line is stirred. You can see that before the store was stirred, we had two distinct zones, this low dry matter zone here and the high dry matter zone at the bottom. After stirring for 24 hours, the depth and dry matter content at the bottom zone has been reduced and the dry matter content of the top zone has increased, although still quite a big increase in dry matter content in the material at the bottom of the store. And you do need to consider this when you're sampling, and also when you're spreading, because the nutrient content of the final few loads may be quite a bit different to the first loads that go out. And it does emphasise that stirring is important to try and as much as you can get a consistent material to spread. And this graph just emphasises the point that I was making in terms of the nutrient content of different trailer loads. As part of the same project, we also took samples of slurry from each tanker load during store entering. Again, this graph is for pig slurry store, and it shows the pig slurry dry matter content and the different tanker loads. And you can see during store emptying, there was a clear difference in slurry dry matter. And also it's got the nitrogen content here between sort of the loads here and the final few loads there. And so the loads going out here are going to be applying quite a bit more nutrients than the earlier loads there. So it's just important to consider that. So once you know what the nutrient content of your manure is, you then need to estimate the crop available nutrient supply. So for nitrogen, the key factor affecting the nitrogen value of the manure is the readily available nitrogen content. So readily available nitrogen, that's the nitrogen that's in the ammonium form that can be taken up by the crop. But if you've got poultry manure, it's the ammonium and uric acid nitrogen form. So these pie charts are from RB209, and they show the proportion of the total nitrogen in the readily available ammonium form for different manure types. And you can see the proportion of total N in the readily available form does vary quite a bit between manure types. So for cattle manure, it's about 5 to 10% for old cattle manure, 20% for fresh. For cattle slurry, it's about 45%, about 35% for poultry manure, 70% for pig slurry, about 80% for whole digestate. Digestate is a high readily available N material, and about 15% for biosolids. So, but it's important also to understand there's a difference between readily available nitrogen and crop available nitrogen. To work out crop available nitrogen, we need to take the readily available nitrogen, add on any mineralization of organic nitrogen, and then take off any nitrogen that's been lost by leaching, volatilization, denitrification. That will then give us the amount of nitrogen that's available to our crop. And what we really want to do is we want to minimize those losses and maximize the crop available nitrogen supply. So we want to, reduce nitrogen notches as much as possible, get as much in the crop. So if we think a bit now about these nitrogen losses and the factors that affect them, The main loss pathways are via nitrate leaching and ammonia volatilisation. So if we start with nitrate leaching, so we know that if you apply manures in the autumn-winter period, when the crops aren't growing and when the soils are draining, we'll lose some nitrogen via leaching. And we know that these losses are greater for high readily available N slurries and poultry manures than for lower readily available N solid manures or compost, just because there's much more readily available N potentially there to leach. And we also know that nitrate leaching losses will increase more rainfall that you have following application. So this graph here shows nitrate leaching losses from a couple of different manure types, a slurry and a farmyard manure, applied between September and January. You can see nitrate losses are higher from the slurries and the poultry manures than from the farmyard manures. This is more available nitrogen there to leach, but you can also see leaching losses are higher earlier in the autumn period, and that's just because you've got more rainfall following application to potentially leach that that nitrogen out before the spring. So the previous graph I showed you was nitrogen leaching work on sandy soils. We know that sandy soils are prone to leaching. Water moves rapidly through the soil by piston flow, and we know that high readily available N manures applied in autumn to sandy soils are high risk of leaching. But what about those of us who aren't on these light or shallow soils? We have, I think, 6.4 million hectares of heavier drain land in England and Wales, equivalent to about 70% of agricultural area. How much does nitrate really leach through these heavier soils? So there are some common misconceptions around clay soils. People tend to think that they're nutrient retentive and the cracks close up when they wet up. This isn't entirely correct. Those cracks that you can see here, they do shrink when they wet up, but they don't close, and there is still risk of nutrient losses from manure applications to these soils when they're wet. So we did a programme of work several years ago looking at nutrient losses from manures to drain clay soils. It was DEFRA funded work that AHDB did with Rothamsted, Northwick. We had 3 experimental sites, Rowdon down at Northwick, Farringdon in Oxfordshire, and Boxworth near where I'm based in Cambridge. So at each of these sites, we worked with hydrologically isolated plots, so blocks of land that were completely hydrologically isolated. So we were able to collect the drainage water from those plots. And as part of this work, we were looking at the impact of slurry application timing, so comparing autumn, winter, and spring, on nutrient losses in drainage water. So I just wanted to pick up a couple of those results to show you now. So this graph here is from our Farringdon site in Oxford. Heavy clay soil. We had half the sites was down to arable plots and half of them were down to grassland plots. So we put, at this site, we put slurry on in the autumn, winter and spring. Now this was, to point out, this was before the current MVZ close spreading periods, and part of what we were doing was testing the impact of these different timings. This graph here shows nitrate concentrations in drain water over the winter period. Now, the red lines are the arable plots, the blue lines are the grass plots, the solid red and blue lines are the autumn applications, the long dashes are the winter applications, and the short dashes are the spring applications. So nitrate concentrations were higher from arable and grass. I mean, we know that there's nothing new there. And on the arable land, nitrate leaching losses were greater from the autumn than from the winter or spring applications. Again, nothing particularly new there. But we also, we didn't just measure nitrate, we also measured ammonium, phosphate, sediment and pathogens. Now this graph is for phosphate. We measured molybdate reactive phosphate concentrations in drainflow, and actually I've picked out the phosphate graph here, but we saw a very similar pattern for ammonium N as well. Now phosphate and ammonium move differently through the soil to nitrate. They're not soluble like nitrate, so they don't tend to leach through the soil matrix, but they will travel through the soil via bypass flow. And on these heavier drain clay soils, we can get elevated concentrations in drain flow if rainfall follows soon after slurry application. And in this particular year, that's exactly what happened. We put slurry on in the winter on the 16th of December, and we got heavy rainfall, 10 mils on the 17th and 18th, and you can see it's coming straight out of the drains there. And we also saw something similar in the spring there. So we put the slurry on the 23rd of March, and we had heavy rainfall a week later, and we were getting peaks in concentrations there. And it was exactly the same with ammonium, and high concentrations of phosphate and ammonium in water are bad news for water quality. Yes, so just again pointing out that, you know, key thing here is applying slurry to drain soils with low soil moisture deficits when rainfall follows soon afterwards. It is likely to result in elevated drain flow ammonium or phosphate concentrations. And this is kind of a potential example of pollution swapping. It highlights the need to be careful if we're trying to do something to minimise the loss of one nutrient, that we don't have knock-on consequences for others. So we might move from autumn to spring because it's good for nitrate leaching, but it just highlights it can potentially, you know, if the circumstances are such that you've got wet soils, heavy rainfall afterwards, it can potentially result in high concentrations of other nutrients in water. And just to illustrate that point, these are water samples that we took 10 days after the slurry was applied back in March 2008, and you can see which plot, which water sample came from the plot that had slurry applied and which one didn't. So quite clear there. And actually, based on this work from these sites, we devised this risk management guidelines for slurry application and timings to heavier drain soils. So, you know, if your soil moisture deficit is more than 20 millimeters, you're probably okay with your slurry applications. If you're 10 to 20 millimeters deficit, you know, at moderate risk. But would say that if your soil is wet, you're less than 10 millimeters soil moisture deficit, you're at high risk of nutrient losses from these soils. Okay, so we've looked at losses to water, high-end losses from high red-available end manures. So we can reduce this by applying manures in the spring when the soils are drier. Now I want to look a bit at ammonia. Ammonia emissions can be a significant loss pathway. We can easily lose a third of our readily available nitrogen as ammonia, and values potentially higher than this for solid manures. Ammonia loss is a problem because it causes acid rain. The subsequent deposition of the ammonia can lead to eutrophication, which can damage sensitive habitats, and also atmospheric ammonium sulfate and ammonium nitrate components of PM 2.5 and PM 10 particulates that cause respiratory disease. Now, I'm sure you've all heard, you know, the majority of ammonia losses from agriculture, about 80 to 90% of ammonia loss comes from agriculture. So that's why there's a focus on agriculture in terms of reducing our emissions. And this pie chart here shows where those emissions come from. And you can see that the majority of them come from livestock or manure handling. So if we want to try and reduce our ammonia emissions, there's got to be a focus on reducing emissions from handling of manures. And there are ways that things that we can do to try and reduce our emissions of ammonia. So for liquid manures, slurries, digestates, etc., we can reduce ammonia volatilization by applying precision kits. So trailing hose, trailing shoe, or shallow injection kit, like you can see here. A trailing hose applies slurry in a narrow band to the soil surface. Research that we've done has shown that using a trailing hose reduces ammonia loss by about 30% compared to surface broadcast. A trailing shoe, it's like a trailing hose, but it has a metal shoe which parts the grass. It's usually used on grassland, parts the grass canopy and puts the slurry in a band on the soil surface. This will reduce ammonia loss by about 40% compared to surface broadcasting. Shallow injection, it's actually placing the slurry in a slot, typically about 5 centimeters deep. This will reduce ammonia losses by about 70% compared to surface broadcasting. And in all these cases, we're reducing emissions because we're reducing the surface emitting area of the slurry. So this is good for ammonia. It's also good for odour, and because it reduces the amount of grass, crop contamination, it helps increase our available spreading days as well. And here we've got a photo that sort of nicely illustrates this point. Here we had applied pig slurry to winter wheat crop. I think the application rate was about 40 cubes per hectare. On this side we used a trailing hose, and on this side we surface broadcast. So here we've got the slurry in bands, and you can see it's kept the crop clean. And you know, if that was your winter wheat crop, I'm sure that you wouldn't want it looking like that. So by using this equipment, it does allow us to apply to growing crops, which facilitates applications in the spring as well. So we can reduce ammonia emissions from our liquid manures by using that sort of kit. In terms of solid manures, or actually any material that you are surface broadcasting, so solid or liquids that you're surface broadcasting, if you are applying to arable land or a grass reed seed where you have the option to incorporate the manure following application, incorporation can be effective at reducing ammonia losses. The graph we've got here shows ammonia emissions following cattle slurry, pig slurry and poultry manure applications. The ammonia emissions are shown as a percentage of the readily available nitrogen applied, and the axis here is days after application. So this is showing you the pattern of ammonia emissions over time. And that's the key point I wanted to get across here, this pattern of ammonia emissions. You can see that the majority of the emissions occurs quite soon after application. So what I wanted to get across here was that if you are going to incorporate the material, the sooner after application that you can do it, the better, because you'll have the biggest reduction on ammonia emissions. And I would say if you're going to go to the effort to incorporate, do it as soon as possible, and you'll reduce ammonia emissions and you've got more nitrogen there available to your crop. So we've seen that when estimating crop available nitrogen, you need to take account of nitrogen losses to the environment, so leaching, ammonia, and we've seen that these losses can be quite variable and depend on a number of different factors such as application timing, method of application, soil incorporation, etc. So we need to be able to provide this information to farmers, growers in a clear and simpler way so you can estimate the crop available nitrogen supply from your manure application. There's a couple of different sort of sources of guidance I'd point you to. So firstly, the AHDB Nutrient Management Guide. That includes a section on organic materials, which has tables which give you availability figures for different manure types and application timings. There's also the Manure software. That's it's a free software tool, Manure NPK, to estimate the crop available nitrogen supply from manure applications. I've still got the CD picture in there. We haven't actually got it on CD anymore, but it is available to download from the Planet website, and that will use specific information from your farm to give you the best estimate that we can in terms of crop available nitrogen supply. And just to show you, this is what the Manure looks like. It's a very simple, easy to use tool. When you open it up, it's got some tabs along the top, so you input some information in terms of your farm. So your postcode to pull up average rainfall data, and soil type. You enter information in terms of the manure that you're applying and how you're applying it. You can enter information on Manure Analysis. You can use standard figures, or you can enter your own values. And then here, the screenshot I've got here is from the results tab. And so what it gives you, it will tell you how much nitrogen that your manure application has applied, give you an estimate of the total amount of mineralization. It shows you what we estimate the nitrogen losses to be, which I'm shown here in red. And importantly, the value you're looking at is this value here, our crop available nitrogen supply. And it also gives figures for phosphate, potash and sulfur as well. So it's quite a useful tool. When we're talking about manure, we tend to talk quite a bit, as I have done, on nitrogen, and a lot of the focus of the research is directed towards nitrogen because, as I've said, it doesn't stay put, and because losses to the environment cause pollution. But for many manure applications, the majority of the nutrient value is actually in the P and K, so it isn't all about the nitrogen. And the data here, some of the values here is going back to the examples that I gave at the beginning of the presentation. So, a cattle manure application, you can see that actually the vast majority of the value in that manure application comes from its phosphate and potash. even for the pig slurry, which is a high readily available end material, actually the majority, still more than 50% of the value, is from the phosphate and potash. So in order to make, so that's an important point, because in order to make the most of that phosphate and potash and maximise the value of that manure to you, it's important that you target these applications to fields which are low in P and K and will benefit from these nutrients, because obviously actually you don't realise that value of the P and K unless you knock back your fertiliser use accordingly. So good to target your lower soil P and K index fields. For phosphate and potash, the general guidance given in RB 209 is that where a crop response to P or K is expected, that you should use the available phosphate or potash content of manure when calculating the nutrient contribution. So where you are below your target soil index of 2 for grass and arable, you should use the available P and K content, which for phosphate is 50% for slurries, biosolids, compost or digestate, and 60% for solid livestock manures. And for potash, it's 90% available for all manures apart from compost, which is 80%. If you are at index 2 or above, we recommend you use the total phosphate and potash content in nutrient management planning. And once you've gone through the steps of working out the nutrient content of manure, estimating the crop available nitrogen, the final part is to make sure you integrate this all into your farm nutrient management plan. So just an example here of pig manure, 35 tonnes per hectare of pig manure applied in the autumn, but applied to oilseed rape. So we're all right with our autumn application because oilseed rape has an autumn crop nitrogen requirement. So just as an example here, so say we were at SNS index 1, P and K index of 2, so we've got a crop requirement of 190 for nitrogen, 50 for phosphate, 40 for potash. The manure nutrients supplies 25 kilograms per hectare of nitrogen, 210 for phosphate, and 280 for potash. I should have entered a value there for the remaining amount you need to apply fertiliser nitrogen. I'm showing one of my kids interrupted me when I was writing this table earlier on, so apologies there, but you've got a balance there to apply in terms of nitrogen. But the point being is that you've got no fertiliser requirement for phosphate or potash, and actually you've got a surplus there that you can carry over for the next crop. So that amount of phosphate and potash may well supply all you need for several crops in the rotation. As well as nitrogen, phosphate and potash, organic materials can also supply crop available sulphur. And AHDB had funded over the last 10 or so years projects that I've worked on actually with James, a couple of projects looking at sulphur supply from organic materials applied to wheat and oilseed rape crops. And this work has clearly demonstrated that these materials can also contribute to crop sulphur requirements. This picture here is from a field site that we had in Southwold in Suffolk. It's a sandy loam textured soil, so sort of high risk of sulphur deficiency. We had a number of different organic material treatments, and we also applied sulphur fertiliser at different application rates. This photo was taken in the spring. You can see at the back here we've got our zero sulphur control, which is, you can see it's visually yellower. Here we've got a fertiliser sulphur treatment, 50 kilograms per hectare of sulphur fertiliser, and here we've got broiler litter application that went on in the spring. And you can visually see here that the broiler litter treatment is more comparable to the fertiliser treatment, and it's supplying crop available sulphur there. And based on this work, we've now able to provide guidance on the sulphur availability from organic materials, and this table here is in the AHDB Nutrient Management Guide and gives us percentage availability figures for sulphur availability for different manure types applied in the autumn and the spring. Once you've determined the nutrient content of a manure and you've estimated the crop available nutrient supply, the next step is important that you spread it accurately and evenly, and you know how much you're applying. So if you're applying a slurry using band spread or shallow injector, that will spread the material evenly, as well as reducing odour and ammonia emissions. For slurries applied with a broadcast spreader or solid materials applied with a rear discharge spreader, it's important that you have an area of overlap when you spread it, so you even out your application rate. And I think basically the key thing, make sure you need to be looking to take the same amount of care over your manure applications as you would do your mineral fertiliser applications. In order to assess application rate, you need to know the quantity of material spread and the area over which it's applied. This is where many fall down. It's actually knowing how much you've put on. For slurries, it should be fairly straightforward if you're using tankers or pumps, tankers of known volume or pumps on known output. For solid manures, you need to know how much manure is in a typical trailer load. The best way of doing that is to weigh a trailer empty and full. And not just guess. This trailer here, this picture here, this trailer contained 12.5 tonnes of farmyard manure. We took it to the grassland and muck event quite a few years ago, and we asked farmers to guess the amount in the trailer. And whilst the average guess of 11.7 tonnes, I think, wasn't far off, the estimates ranged alarmingly from 2 to 24 tonnes. But if you can't weigh a trailer, you can still estimate the amount that would be in that trailer by estimated capacity, so length, width, depth plus overfill, and then taking into account the bulk density of the material, which for manures it's typically about 0.7 tonnes per metre cubed. Okay, so just the final few slides, which I'll try and skip over quite quickly because I think we're getting tight for time. So I've talked about manure nutrient content and the value of the nutrients in manure. We also know that manures are a valuable source of organic materials. We know that loss of soil organic matter is a major threat to soils, and applying these materials back to land can help us increase soil organic matter. We all know that soil organic matter is good for a wide variety of reasons. It includes soil structure, workability, water holding capacity, biological activity, etc., etc. Basically, if you're trying to improve your soil health, building organic matter is key. And organic materials, they have a nutrient value, that's, we've covered that. They also have a value in terms of organic matter, and that actually is much harder to put a pounds value on. What I've got here, this table just shows the amount of organic matter applied from a few different types of organic manures: cattle manure, broiler litter, compost, green food compost, and digested biosolids. So this is based on typical application rates, targeting applications that bring us in at below the MVZ 250 kilograms per hectare limit. So, and this here shows the range of amounts of organic matter applied. So broiler litter at 8 tonnes per hectare is applying about 2.5 tonnes per hectare. Cattle FYM 5.5 tonnes per hectare, green food compost 5 tonnes per hectare. Returning these materials to land, good source of organic matter, and we've got a range of other studies which I haven't got a chance to go into, which has shown tangible increases to soil quality as a result of long-term applications of these materials. So finally, to summarise, to maximise the value of organic materials in agriculture, so what do we need to do? First, use a crop nutrient recommendation system such as RB29 to assess your crop nutrient requirements. Target your manure applications to crops which have a requirement for nitrogen, phosphate and potash. Estimate the nutrient content of the materials that you're applying. Apply them accurately and evenly at an appropriate application rate, and where possible, take steps to minimise nitrogen losses via leaching and ammonia volatilisation. Use a nutrient management plan to take account of the nutrient supply from organic materials and reduce your bag fertiliser use accordingly. And finally, I know we haven't had much time to touch on it, but just emphasising that these materials also have quite a bit of value in terms of their organic matter content and helping us improve the organic matter content of soils. So hopefully I haven't gone too far over. And finally, I'd just like to acknowledge the input of a large number of ADAS colleagues, past and present, to the work that I presented tonight, and also funding of the work by DEFRA, AHDB, RAP and others. Thank you very much. I'll just stop sharing.
Thank you, Lizzie. That was a great run through. We have got lots of questions come in, but I'm tempted to give you a moment to breathe and to have and we'll start off with some questions to James and we'll go from there. So we talked about the implication of the rules, particularly affecting the auto applications of products. When we talk about auto applications, what do we mean, James? What is autumn?
It's a good question. Effectively, I think it means after the harvest of the previous crop. So if you're talking about a cereal crop harvested in the summer, anything that you do after that would be considered then the autumn. Until when is a good question, because autumn really, strictly speaking, extends into certainly the early winter. And then in terms of late winter, early spring, you're getting into a slightly more grey area. I think if you're concerned at all, it's best to speak to your local Environment Agency officer in terms of, and that goes to any aspect of the rules really. And, without wanting to speak to them, they generally speaking, pretty open to that discussion. And I think they understand that there are many challenges posed by these rules. And are very open to that discussion. I think, particularly in terms of timing as well.
Brilliant. And you are having various conversations with the Environment Agency and people like that. And are they open to conversations with AHDB and other organisations? What's your feel at that?
Yeah, absolutely. I think, particularly at the local level as well, where farmers are, I think, are probably going to be interacting most effectively, is have that discussion with the local EA officer and talk to them about, the challenges that you face. They will understand and they will try to help as much as they can.
Brilliant. And then a question to you both to see who can get to the paid reference fastest in RB209. Where can people find the organic matter values of manures in RB209? So first to answer, where are people heading in RB209 for those nutrient values?
It depends on the. Sorry, not to answer the question, Jerry. It depends on the element, on the material. But it's section 2, which I think is the section that you highlighted, Lizzie, as well. And I can drop a link into the box. But section 2 of RB209 contains the nutrient content for vast array of materials, from biosolids through to duck manure as well. So and it's all in there. And I dropped a couple of links as Lizzie was speaking. I dropped a couple of links into the chat to the videos on how to sample. Just very short videos. Yeah, and actually, it's a very simple thing to do, really. Not something you need to overthink. Just, kind of take those samples from across the heap, for example, for farmyard manure, bag up a representative sample of that and send that to the lab. And it as Lizzie says, it can be really, really informative, because you can have, not always, but can have quite different values in your own material.
Brilliant. So we briefly actually talked about this before we started the webinar, but we've had a couple of questions related to the composting of manures and how that could potentially fit and what effect that has on the nutrient values of the product. So I don't know whether you have any thoughts, Lizzie.
Yep, so I must admit, we said I thought this question might come up. I mean, in terms of the relative benefits of spreading material relatively fresh as opposed to storing it or composting it, I would say that the key benefit and reason why we store manure is in order to be able to spread it at a time that's convenient to you. In terms of composting, if you compost a manure, you are going to increase ammonia volatilization. So you'll increase your ammonia loss and you'll reduce the nitrogen value of the material. I would say a key benefit to composting is that you're going to get a more friable material to spread. In terms of the impact on nutrient content, you'll reduce its nitrogen value. I think there has been interest recently in terms of relative soil quality benefits of different treated manures, and I think for me the jury's out. I don't think that, I haven't yet seen really good evidence to suggest that there's a particular benefit of composting in terms of the soil quality benefit compared to applying the material fresh.
Brilliant. And then we talked about testing organic materials. Is there a benefit to testing it multiple times per year? And then following on, is it best to then test just before you go to spread it? When's the best window? How stable would it be? And do you need to be looking at it multiple times through the year?
Yeah, no, that's a good question. I would be looking to test before you spread it, because you're testing material that's most similar to the material that you're going to spread. I would say that for you on your farm, it's useful to start building up almost like a database of your own manure analysis. So, I mean, it depends how much material you've got and whether you've got different stores, but, you know, getting a couple of samples a year, once every 6 months or something, and then starting to build, you know, put that into a spreadsheet and start to build up a picture, because also that will give you the advantage that, you know, if you happen to ever get a spurious result, you'll see that, and you can always send a sample for reanalysis. And that does happen. It might be that, you know, you sampled an atypical area, or it might be there was a, you know, an issue at the lab. But I think definitely start to build up a picture of the material that you've got on your farm. And I wouldn't just do it once, you know, take some samples, but then, you know, repeat it over time. And in terms of the exact number, it's a bit difficult. It depends on your farm and how frequently you're spreading material.
Brilliant. And then we'll flip back to James for a bit. So we've talked about the rules, and is there a place at least for cover crops? What's the implication of the rules if we grow a overwinter cover crop, or equally something like stubble turnips? Is there any scope for use in those sorts of crops?
Good question. Effectively, no, I don't think there is. Within what the Environment Agency are trying to do is reduce that nitrogen loss, and the cover crop. You know, there's lots of talk about whether a cover crop, you know, benefits, you know, in terms of biomass, and but there's not a huge amount of evidence. You know, I think it can be very variable. You know, to be fair, where you see trials and there's a benefit. For somebody like AHDB to provide national guidance, certainly in terms of the context of RB209, that's very challenging to do, and the data just isn't there. And so, in any situation, if you have evidence that there is a nitrogen requirement, so I'm not talking specifically here about stubble turnips or any cover crop, but if you have evidence, you know, good solid evidence that the crop requires you know, nitrogen in the autumn and the winter, and there are examples, and Lizzie, you've done some work with us on leeks, for example, perhaps quite a niche crop in terms of this audience, perhaps, but you know, there are crops that do benefit in terms of yield or quality from an addition of nitrogen, and it's difficult, and it's actually not the place for AHDB to say exactly where that's always going to be. We publish RB209 because there's a huge benefit to farmers from having, you know, independent information on the use of nutrients. And I appreciate I'm going kind of a little bit off piece here, Michelle, but I think the point is essentially it can be very difficult to provide exact guidance. But if somebody has, you know, evidence in one form or another that you can discuss them with the Environment Agency, there is an opportunity. And again, I'd go back to talking to the local officer, talk to them about your situation, talk to them about the crop, talk to them about the evidence you have, and they're certainly going to listen. And I think to be fair, they're really going to, you know, they're going to work with you on that as well. But in terms of, like, strictly speaking, is there any guidance? There's no guidance in RB209. There's no guidance at AHDB that, you know, specifically around the use of nitrogen in the autumn or winter.
Fab. We'll go to Lizzie again. We've got a lot of questions about how farmers can go about understanding their soil moisture deficits and how that can be calculated. There is a spin-out question for James about whether there's a place for AHDB to provide that information. So certainly one to think about, James, as well, whilst we talk about how farmers can calculate it.
That's actually a really good question. I probably should have thought about that before I start putting slides like that up. I'm not immediately sure. Obviously, we've got models that we run that sort of ongoing to look at soil moisture deficit. I'm not immediately sure off the top of my head where farmers could go to look at that. Although, I mean, it's looking at your soils. If where you haven't got a soil moisture deficit, your soil is saturated, and if it rains, the drains are running. And I guess that's really the key thing in terms of risks in the spring from applications of these materials on drain clay soils. If the soil is saturated and the drains are running soon after rainfall, then that's high risk. You know, you really need the soils to start to be drying out a bit, and know that your drains aren't going to run instantly following rainfall to try and reduce that risk. You know, if you're having to go on a frost because your tanker would sink into the soil otherwise, it's probably not a good idea.
And James, any thoughts over how we can make that data more accessible for farmers? Is there anything we could do?
We don't provide that data at the moment. We provide data on excess winter rainfall, but that's quite a specific piece of information that you use to calculate a soil nitrogen supply, combining with essentially a measurement of soil mineral nitrogen in an arable situation. It could be really interesting actually, and it's perhaps worth highlighting the fact actually with the price of nitrogen as it is, it's something perhaps to consider that a measurement of soil mineral nitrogen in quite a specific situation can be beneficial and can potentially in those situations give a more accurate estimation of the crop's nitrogen requirement. Of course, that could be less or more, so is not, you know, a panacea. But AHDB does provide what's called excess winter rainfall, estimates of excess winter rainfall down to 40 square kilometre grids across the UK. And again, I'll drop a link to that. In terms of moisture deficit, it's not something we currently do. I'm not exactly sure how we would do that and if that's feasible at a local level. I think that's maybe something me and Lizzie have to have a quick discussion about, and we'll answer at a late stage.
The person that asked the question gave the hint that maybe Chuggers are providing that sort of data, so it's certainly something we should have a look into. So that's something to look at. Thinking about the rules, so it's a simple question: are these rules actually legislation? How does it fit with that? Is it the legislation now that is bringing these rules in?
No, it is. It's a series of rules and regulations with I believe a strategy instrument that was introduced in 2018. Of course, like most things, it's an interpretation that has been developing within the Environment Agency over a number of years. And I mean, that's not necessarily entirely fair. I mean, I don't work for the Environment Agency, you know, that's obviously very clear. And I'm not a spokesman for them, but the rules, the 8 rules, you know, they're very specific rules were introduced in 2018. Exactly what that means in terms of land management, and I think this is applicable to any rule, is it can be interpreted perhaps in different ways, and the requirements that the Environment Agency expect farmers to meet have developed. I think that's fair to say over the last couple of years, and are now, you know, are now clear in the sense that they're written down and they're posing quite a significant challenge, and that was legislation that was brought in by DEFRA in 2018.
Brilliant. So we talked about phosphate pollution and things like that. Can we talk about how it actually gets into the watercourses? What's the main route of pollution with the phosphate?
In terms of phosphate, it does. I think I picked up. It behaves differently to nitrogen. It's not soluble like nitrogen, so it doesn't leach through the soil. It tends to move. One of the main sources is overland flow. So it tends to bypass the soil matrix. So if you've got any water running over the soil surface that's attaching soil particles, that's high risk of phosphate losses. The data that I showed from some of those heavy drained clay soils, we were getting high phosphate losses there, because the rainwater was interacting with the slurry at the soil surface, and then it was bypassing the soil matrix, so it was going through cracks in the soil profile through to the drains and out of the drains. So if the water has to drain through the whole soil matrix like a sand soil and red piston flow, you don't tend to get as high phosphate losses.
Brilliant. And then we're going to end with this last question, and it's how can farmers preserve the nutrients in the muck to make the most of them? So we'll leave on that note because it's a very good note to finish on. So how can we preserve the nutrients available in the muck to make the most of them?
In terms of, well, I mean, the key one you need to look at is nitrogen and minimising the losses. So I would say during storage, trying to reduce any losses during storage. I mean, sheeting can help retain ammonia in the heap of storage. And then when you spread it, ideally spread it in the spring to minimise your nitrate leaching losses. And either if it's slurry or liquid material, band spread or shallow inject, or if it's solid material and you're applying to bare soil, incorporate it. So before we go, can I just say, because the question on soil moisture deficits, as I was answering that, I was probably thinking I've probably got ADAS colleagues listening that are shouting at the screen telling me where you can get this data. And I've just checked, and it is something that we provide in crop action. So there is obviously a way to get that. And James, I can let you know about that later.
Wow, thank you very much. That's brilliant. So all that leaves me to do is to bring us to a close. So I'm just going to share the last few slides and remind you all that as you leave this webinar, you will be taken to a survey. If you could fill that in, that really helps us out with direction of further webinars and all of those sorts of things. So please do give us your feedback. As I mentioned at the beginning, this webinar has been recorded, and along with all of our other webinar recordings, it will be available on our website and YouTube channel in the next few days. So if you want to revisit anything, please do. If you haven't already, there were basis and Naroto points for today, and you can let us know your details. And equally, if you do stumble across our webinar channel, there are basis and Naroto points for pretty much all of our webinars. So if you do find yourself short of points at any time, go and visit our recorded webinars and we can accredit some points for that. If you want to get in touch with anybody, there are our contact details for the speakers tonight, for James and Lizzie. Do get in touch. We will do our best to answer any questions. And then dates for the diary. There is an awful lot going on. The Knowledge Exchange team and Cereals are just about to kick off with their winter series of Monitor Farm meetings. So there should be events local to most people. So we'll encourage you to go and have a look at that. Also coming up this month, for the 15th to the 19th of November, is the Strategic Farm Week, where we look at the results from the Strategic Farm trials across the last season. On the 7th of December is the Agronomist Conference, where we'll be looking at all the data coming in from the last 12 months. And also next month's webinar, we understand that fertilizer prices are a big issue at the moment, and thank you for those of you that sent them in during the webinar. But the December monthly webinar will be focusing on costs and the implication of the increasing price of fertilizer. Thank you very much for joining, and thank you for James and for Lizzie for giving up your time for this webinar. It's been great chatting with you tonight, and I hope you all have lovely evenings. Thank you very much.
Thank you.
Thank you, everyone. Good night.